Today we're going to talk about scatterplots, correlation, and interpretation of scatterplots and correlation. We're on page 43 in your notes packet, and the first thing that we see is a little review of some models that we can use to sort of relate data. So we can have data that follows a linear model, something that looks like a line. We can have data that follows an exponential model, and that could be growth or decay. Or we could have a quadratic model. Here we have a quadratic model that would have a negative leading coefficient. We could also have a quadratic model with a positive leading coefficient. We could see other types of polynomials as models. We could see all different types of things, but these are the three that we're going to focus on for today. The first thing I'm going to do is sort of refresh what each of these models look like. So on your calculator, I would like you to create a scatter plot out of each of these tables and then determine the function that best fits the information you get. What model would be appropriate for that information? So we'll go through the first one together. I'm going to get out my calculator, and then I'm going to make a list and spreadsheet, and I'm going to recreate this table in my calculator. Don't forget to name your columns. So I'm going to call them X and Y, just like they're named on my paper. I'm going to enter the data, so enter those X values. And then, enter the Y values. Don't forget to push enter after you type in that last value. And then I'm going to hit Control Doc to add a data and statistics page. I'm going to click at the bottom and assign my X variable. I'm going to click along the left and assign my Y variable. And then I'm going to look at what pattern I see here. So to me, this looks a lot like a parabola that's opening down. So I'm going to choose to say that this is a quadratic model, and I'm going to have it show me the actual function that would model this information. I hit Menu, then I went to Analyze, and I'm going to go down to Regression, and I'm going to have it show me a quadratic regression. So up on my calculator, it will draw in that model for me that I see here, and it will give me the function that describes that model. And so on my paper, I'm going to write that I used a quadratic model, and my model was y equals -1 x squared plus 7x minus 6. Be careful again with your signs in here. Make sure you don't miss out that that does say -6. So I want you to try the same thing with 2 and 3. Create those tables in your calculator and decide the model that best fits them. You can pause this video if you need to, but this would be our scatter plot for number 2. So if you need a little more time on number 2, go ahead and pause. But here's our scatter plot for number 2. A lot of people would say that this sort of looks like half of a parabola. My issue with calling this a parabola or saying that this is a quadratic relationship is how much we taper here. If this were going to be a parabola, I would expect us to start coming back up by the time we hit this point. Since we're not doing that, I would say this looks like an exponential relationship. So I'm going to test that by looking at an exponential regression here. Show exponential, and that seems to fit our data pretty well. So I'm going to say that number 2 is an exponential model. And my function from my calculator is y equals 4 times 0.5 to the x. And then same idea with number 3. Again, if you need to pause to finish number 3, go ahead and do that now. Here's our scatter plot for our data for number 3, and this is pretty clearly a linear model. So if I analyze and get it to show me a linear regression, notice we have 2. We have mx plus b and a plus bx. We're used to using mx plus b, so I'm going to use that. And we get, again, a line here, and I'm just going to move my function over here so I can see it a little better. This is a linear model, and my function is y equals negative 4x plus 5. Okay, all of this you've done before, particularly those quadratic and other polynomial models. We covered those last semester, so this should be familiar. Just a little refresher on how to find these using your calculator. So when we talk about using models to describe information, we first need to decide what type of model seems to best fit our scatter plot, which is sort of what we just did. But I want to talk about how good our models are, or how strong our correlation is. So when we talk about correlation, we have a few different examples or types of correlation that we're going to look at for today. We'll see some linear correlations, either strong, moderate, or weak, and we'll also see some nonlinear correlations. Again, those could be strong, we could say moderate, but we won't see any examples of those today, or they could be weak. When we talk about correlations that are linear, we also need to talk about if they are positive or negative. Essentially, would that line have positive or negative slope? And then we could also, again, have no correlation. Maybe there isn't a relationship here between my variables, between my things that I looked at. So if I take a look at all of my examples here, I'm trying to fit them all in this picture as best I can, I would say that 1, 3, 5, and 4 all look like linear relationships. 2, I can see a relationship, but it doesn't look linear. 6 is kind of the odd man out for this bunch. There is no relationship here. I've got points all over the place. There's no correlation between if this variable increases, what my other variable does. So 6 is no correlation. Which would be, if I use my code up here, F. F, no correlation. For my linear relationships, 3 and 5 are some good examples of strong linear relationships, which would be A. I have strong linear correlations for 3 and 5. I have a very clearly defined line there out of my data points. The difference between 3 and 5 is that one of them would be aligned with a positive slope and one of them would be aligned with a negative slope. So I would say 3 would be a positive correlation, while 5 would be a negative correlation. So 3 I'm going to call G, and 5 I would label as H. 1, it also has a linear trend to it, but my points aren't grouped as closely, so I would call this a moderate linear correlation. This line would have a positive slope, so it would also be classified as a positive correlation. 4 is what I would define as a weak linear correlation, which is C from our options at the top. I would call this a weak linear correlation because while I can see this linear trend, my lines are not at all, or my points I should say, are not at all closely grouped together. So I would call this a weak linear correlation. The trend is that of a negative slope, so I would also say that this is a negative correlation, H. And then finally, 2, this is obviously not linear. It looks like maybe it could be a cubic function. It could be a different type of function, but it's clearly not linear, and my points are pretty close together. They follow that trend pretty closely, so I would call this a strong nonlinear correlation. One important thing to remember that we talked about with our sampling and our data collection is that it's important that we're talking about these as correlations and not as causations. Okay? A relationship does not mean that one thing caused another thing.